Good morning or good afternoon, depending on where you are. Thank you for joining us today to the iPads in the Classroom webinar brought to you by Xeris. Before we get started, a couple of reminders. You can ask text questions throughout the presentation. Please find the floating toolbar in the top of your console, select the Q&A option, type in your question, select all panelists, and click on Send to submit your question. If you experience any technical difficulties during today's event, please press *0 on your telephone keypad to be connected with an operator. Presenting today, we have Perry Correll, Director of Product Marketing for Xeris, and guest speaker Kobe Gurr, Land School Product Line Manager at Stoneware. Perry, you may begin.
Thank you very much, Josh. And once again, I also welcome everybody who's attending the webinar today. It was actually kind of good timing because yesterday I got an email from eCampus News, and basically it was their May newsletter, and it was real interesting. And if you don't get it, I'd recommend signing up for it because it talks about how schools are actually having to deal with a larger demand on bandwidth. And in fact, approximately 20% of schools now have started limiting the amount of devices students can show up with because, you know, we talked not that long ago about 1-to-1 or 2-to-1. Now individuals are showing up with 3, 4, or 5 different devices, and there's just absolutely no way they're being able to handle it in some environments. So they're actually looking and restricting as far as how many devices people can have and even how much bandwidth they can use. So they're thinking about maybe giving them a fixed amount or an average amount of bandwidth, and above that they might actually charge them more. And as one individual actually was quoted in it, it says that they've seen this growth, and it's been like a hockey stick, obviously the big curve up, and he keeps expecting it or keep waiting for it to level out, and it's not doing it. So obviously this is just going to continue to be a problem as we go forward, which is the whole point of this call today. Basically, we're going to talk about what's happening with iPads in the classroom, but it's not just iPads, it's also tablets, it's handheld devices and stuff. And the advantages, this technology advantage is tremendous, but it's also obviously a challenge for IT staff. So what we're going to look at today is a little bit about what's happening on the wireless side. Basically, we've reached that tipping point. I would pretty much imagine that 90% of the people on the call here have tablets. And if you try to find an Ethernet port on that tablet, it's going to be really tough. So we are absolutely into a wireless edge as far as the network is concerned. We're going to talk a little bit about Wi-Fi technology, a little bit more about the client, because that's very, very important. A handheld device, a tablet, a smartphone, is not the same type of device as a laptop, and you need to understand that, and you have to design your network for it. Then we're going to look at a case study and obviously talk a little bit about Xeris and Land School. So that being said, we can kind of get started. This is kind of an interesting slide that I really like, and it kind of shows what's happened just in the last few months. Obviously, Christmas was a very exciting time for a lot of kids because on Christmas Day of last year, there were over 7 million smart devices activated, and many of those devices showed up on campus that following January. As you can see in the third set of bullets down there, the increase from Q4 to Q1 in higher ed was 30 to 40%, and in some K-12 environments, it was up to 80%. So a lot of devices showed up. Above that, you can actually see what's happening daily. I mean, you have, and these numbers change almost on a monthly basis, and they're always going up. So right now you've got about 450,000 iOS devices being activated daily and about 750,000 Android devices. Now I understand that not every one of those has Wi-Fi capabilities, but obviously more and more devices do have Wi-Fi along with their cellular type capabilities. And what's coming up is the very bottom one, that most estimates, they're starting to actually look at this as a conservative number, that by 2015 there's going to be over 7 billion mobile devices, and a very, very large percentage of those will be Wi-Fi enabled, and they will show up on campus. And that's really what we're going to have to design for and plan for going forward. To that end, before we talk about what we're going to do and what we can do, it's very, very important to understand really where we've come from and what's going on in the future. So 802.11 Wi-Fi is actually a rather mature technology. It's been around for almost 15 years now, over 15 years now, because 802.11 was first ratified in 1997. It was only a couple of megabits, so it really wasn't seen as it was just kind of a nice thing to have. A couple of years later, in 1999, 802.11a and 11b were both ratified, which gave them a little bit more capabilities. Obviously, 11b was limited to only 11 megabits per second, and it was very inexpensive, and most people went with that route, operating at 2.4. But 11a, operating at 5 gig, gave it a lot more capabilities, but it was very, very little implementation of this because those devices at that time operating the 5 gigahertz band were much, much more expensive. A few years later, 11G came along, which was really an upgrade to the 11B, still operating the 2.4, and basically put it on par with 11A as far as the amount of bandwidth available, and that became the primary technology for some time. A few years back, 11N really kind of, showed up everywhere, and that's really, a lot of people think of 11N as kind of a high point of Wi-Fi, where we all wanted to be, and in reality, it's a starting point. It actually was the point where wireless now had similar performance capabilities as a wired network, and I'm not going to get into that debate of, shared versus direct connectivity. But basically, the whole idea of 11N was get up to 100 megabits worth of usable throughput. And as most people know, 11N pretty much offers data rates from 65 megabits all the way up to 600 megabits per second. Most vendors today are offering products that operate in 300 megabits per second or 450. Xeris offers a 450 product. Several other vendors also do. And that's probably where we're going to stay as far as 11N technology. As I said before, 11N is designed to go to 600 megabits per second. However, there are other technologies coming along, and the most important is TATO 2.11ac. 11ac is actually designed to go to over a gigabit. 1.3 is actually its theoretical speeds right now. But be aware that there's going to be products coming out at the end of this year, and really consumer-based, residential-based products. You're probably going to see a lot more interest in 11ac for the enterprise class product, the campus class product in the second half of next year. There's still some more ratification and interoperability testing to be done, but that's actually going to probably be the future for the Wi-Fi, and it's seen as obviously an upgrade to the 11A and to the 11N operating the 5 gigahertz. As you can see on this slide, 11AC only operates in 5 gig because of the advantages associated with 5 gig and also because of some of the limitations associated with 2.4. So right now, 2.4 11N is pretty much the high point. Really, most 11N 2.4 devices really operate about 150 megabits per second, even though in theory they can operate in 300. But this is kind of where we're going in the future, and there's a lot of other things happening. You've also got 802.11ad up there, and they talk about speeds from 5, 6, 7 gigabits per second. But be aware, this is not a traditional upgrade to Wi-Fi. This operates in the 60 megahertz range, so it's actually a totally different technology involved here. Obviously, all the devices, all the client devices would have to change to actually support the 60 megahertz. But be aware also, or gigahertz, excuse me. Be aware also that even though with those higher data rates, those higher speeds, it's actually going to be very, very short distance technology. So it's really more designed for residential use rather than enterprise or campus type use. So let's kind of give you an idea of where we're going in Wi-Fi in the next couple of years. The other thing to understand is the difference between the 2.4 and the 5 gigahertz type technology. And it's very, very important to understand that there is nothing wrong with the 2.4 band. There's nothing negative about it. The only problem is it has a lot of limitations. Depending on where you're located in the world, you either have either 11 or up to 14 available 2.4 channels that you can select. But it's very important to understand that a Wi-Fi channel encompasses multiple 2.4 channels. And what I mean by that is if I deploy a device and put it on channel 6, a Wi-Fi channel is actually at least 20 megahertz wide. So that Wi-Fi channel is actually going to extend from channel 4 all the way up to channel 8, which is why you're limited to the amount of channels you have in the 2.4 band. Most people say there's 3 channels, 1, 6, and 11 in North America. In other parts of the world where you have up to 14 channels, some people squeeze a 4th channel in there when you're using channels 1, 5, 9, and maybe 13 or 14. But in any case, you are limited to the amount of channels you have. On the other hand, in the 5 gigahertz band, once again, depending on where you are in the world, you have up to 24 available channels that are non-overlapping, non-interfering. So it's very, very important to understand that as we go forward, as we have more and more devices, and we have to deal with higher and higher density requirements, we need the additional channels that are available in 5 gigahertz. The 2.4 will always be here. We will always need to support 2.4, but the whole idea is the new generation of products, the new tablets, some of the new smartphones and whatever, they all support the 5 gigahertz, so we definitely want to move those devices, encourage those devices to operate in the 5 gigahertz as much as possible. That gives them a better experience, and at the same time, it reduces the amount of devices that are operating in the 2.4 band. So basically, it's a win-win for both bands, for everybody. So once again, 2.4, a lot of the smartphones operate in there, a lot of video systems, a lot of projectors, printers and stuff, a lot of point-of-sale devices. But most of your laptops, your newer tablets, all do support the 5 gigahertz band also. And be aware, if a device supports the 5 gigahertz band, just about 100% of the time it also supports both bands. So by saying it's a 5 gigahertz device, what you're really saying it's a dual band device and will support both. So whether you're supporting a BYOD environment, whether you're purchasing devices, you always want to look for devices that support both bands. The other important thing to understand is about the clients themselves and what's going on. This is a recent quote from Gartner that says, without proper planning, enterprises deploying iPads will require 300% more Wi-Fi. Now that's a great quote, and obviously it makes people take a step back and try to figure out what's going on here. But it's also very important to figure out what they mean by 300%. Does that mean that I need to go from 11G 54 megabits per second to 11N 300 megabits per second? Is that what they're talking about? Or are they talking about I just need to add a bunch more APs in my environment? And so that's very, very important to understand this statement and how it actually applies to clients, and that's very, very important. So let's take the iPad or any traditional tablet, for example, and look at some of the misconceptions people have about deploying these. The first thing to understand is that the tablet is a totally different type of device. I cannot have a room full of laptops and replace those with a room full of iPads and accept the same experience, the same Wi-Fi experience. It isn't going to happen. Because of the physical size of a tablet, because of the physical size of the battery, because of what they're designed to do, they do not have the same capabilities of a laptop. A laptop today typically has multiple antennas in it. It has a pretty good battery. So basically with a laptop, I can get 300 megabits per second or 450 megabits per second of throughput, in theory, in Wi-Fi. A tablet, because most of those have much smaller batteries, they don't actually have the transmit power. Also, many tablets don't have what's called MIMO capabilities that enables 11N to get the higher data rates, and they also have smaller antennas, which typically means less gain. So the bottom line is the Wi-Fi capabilities of a handheld device, whether it be a tablet, whether it be a smartphone, are going to be significantly less than that as a laptop. So you have to understand in those mixed environments, you're not going to get the same capabilities. If I have a laptop and a tablet and a smartphone all sitting on a table, all connecting to the same access device, it will probably give you totally different throughput numbers, and it's very important to design for that. The next thing to understand is you can't just throw APs at the problem. You can't just add even more bandwidth. What you have to do is make sure you understand what the clients are doing and separate those clients across different radios. Separate them based on whether they're 2.4 or 5. But more important is separate them based on what their capabilities are. Is an 11A device? Is an 11N device? If it's an 11N device, can it support 150, 300, 450 megabits per second? The bottom line, it's not just about connectivity, it's about density, and it's also about optimizing what the users connect to. And the final thing is to understand use cases, and this is very, very important. Everybody today tends to want to watch video on their wireless devices. If I have a laptop, I have a device that can very easily support video. I've got a nice screen, plus I also have a very, very good Wi-Fi capability. If I have a smartphone, yes, I can watch video, but basically I have a 3-inch screen, so I'm probably not going to watch a lot of video. It's not really optimized for that. So a smartphone really doesn't have a good display, and it also has a very, very weak Wi-Fi capabilities as far as what its throughput's going to be. The problem is with the iPad, the problem is with the tablet, because you have a beautiful display, so it's optimized for watching videos. But at the other hand, it has a very inferior Wi-Fi capabilities. It doesn't give you the same Wi-Fi capabilities as a laptop would. So that the whole issue is now I've got everybody using tablets, everybody using iPads, and they want to see all this video from the web, but they just don't have the Wi-Fi capabilities to give me the throughput that I want. And we can see that here is understand what those actual requirements are. I want to kind of start at in the middle here a little bit and kind of talk a little bit about something. Is that most people, when you think of 11N capabilities, the first thing they think about is, okay, I can do 300 megabits per second. I can do 450 megabits per second. The problem with that is in order to support those 11N speeds, you have to support all the 11N capabilities. Your laptops, because of their physical size, because of the way they've been designed for the last several years, can do that for the most part. The problem is that tablets can't. In order to support this 300 megabits, 450 megabits per second, you have to have multiple antennas and use something called MIMO technology and do bonding of channels and stuff. The issue is that tablets can't do that today. So in reality, the max you're ever going to get out of the current tablets that are shipping right now, whether it's an iPad or another, is 65 megabits of Wi-Fi data. And as most of you know who've worked with Wi-Fi before, your actual usability is always going to be about half that. So it's very, very important to understand if I have a room full of tablets and they're all connected on an 11A or an 11G network, and I upgrade that network to a 300 or 450 megabits per second 11N network, you might not see any improvement in throughput at all because it's limited by the tablet's capabilities. And once again, the tablet can only connect up to 65 megabits per second. It doesn't support bonding capabilities. The good thing is that the new tablets do support 5 gigahertz, so you can take advantage of that. The other thing at the bottom is low transmit power. Because you have a smaller battery, because you have less capable antennas, you need a much, much stronger signal for a tablet than you would for a laptop. In fact, what you need to design for is something called -65 RSSI, Received Signal Strength Indicator. If you try to design a network for tablets, as you did 2 or 3 years ago for laptops, you're going to have very poor experience. This has got nothing to do with the Wi-Fi vendor. What it has to do is the requirements of the clients, whether it's a tablet, whether it's an iPad, whether it's a smartphone or whatever. It requires a much, much stronger signal to get a similar capabilities of a laptop. And once again, you'll never actually get all those capabilities because a laptop is optimized for it. So it's very, very important to understand that. And then we'll talk a little bit more about that first bullet, is that how many devices can I actually put on a radio? The other important thing to understand is reality. You know, we all see these numbers of what my throughput could be per device. However, if I'm doing testing and we're doing, in a very, very controlled environment, I can get max throughput out of every device based on where I put it and how I set up my network. What you're seeing here is reality. If you have a mixed environment, a production network, you're going to have users connecting at every possible data rate out there. And because Wi-Fi is a shared technology, it's a shared medium, basically the slower devices are going to basically impact your overall throughput. Every device is going to talk at the max data rate it can talk, but because I have to wait for other slower devices, it's going to, obviously degrade my entire network performance. So if you look here, in the upper left-hand corner, I have a laptop that, theoretically can do 300 megabits per second. Down in the middle, I've got a smartphone that maybe can only do 6 megabits per second. That means it takes that smartphone 50 times as long to send the same message as that laptop does. And once again, they're in a shared environment, and you just have to deal with it. So this is reality. Every vendor, everybody can give you these great testing of what the actual throughput is, but this is what you're going to have to deal with in public environments and obviously education environments with BYOD, because people are going to bring totally different classes of devices on campus. So how do you design for it? What do you do for it? One of the first things is kind of look what Gardner said before. Again, by 2015, 80% of newly installed wireless networks will be obsolete. They're not talking about the stuff that was installed 2 or 3 years ago. They're talking about the stuff that's being installed now, because people are still designing for coverage, or people are still designing with the ideas, I can just throw bandwidth at the problem and it will fix everything. It won't. So what's important is to understand what's going on in your network, and actually then you can make better decisions. The first thing to understand in designing is for signal coverage is you've got to have strong enough signal everywhere. And as I said before, the tablets and the smartphones require better capabilities, improved signal strength. So you need to design from the beginning to support tablets. I don't think anybody out there believes that a tablet is a fad and it's going away. Basically, that's becoming the primary product for a lot of people, especially for students. And as the tablet performance continues to improve, you can obviously see it take a lot of business away from laptops. I was at a presentation the other day, and there was 100 people in the room, and I would say 80% of them had tablets versus a laptop. So you have to design for that. The other thing is you have to design for 2.4 and 5. Basically, you need full coverage in both those bands across your environment. And obviously that becomes, sometimes that's that's the smart thing, that's the right thing to do, but sometimes that's also a financial decision. Maybe you can't do everywhere at the same signal strength, but you've got to be smart about it and got to think this through because you will have to do it eventually. And as I said at the bottom, you have to design for negative 65. You know, if you try to design for what we did a couple years ago, negative 72 for laptops or negative 80 just for coverage, your users are going to have a poor experience. And if instructors are expecting to use Wi-Fi to deliver the educational content, it's going to have to be a wired-like experience, a quality experience. So design for negative 65, and obviously, you know, you can do predictive surveys or you can do live site surveys to design your network, but obviously after it's deployed, you definitely want to use a live site survey or some way to walk around and verify you have coverage everywhere you need and at the levels you need. The other thing to do is understand the impact of density on performance. And, you know, one of the questions that always comes up is like, how many people can I put on a radio? That question can't be answered because it depends on what kind of user experience do you want. If I want everybody to have a wired-like experience in a classroom, I want to limit it to less than 20 people per radio. If I'm trying to cover an auditorium where, you know, I'm not necessarily guaranteeing a high-quality service, I could put 30 or 40 or 50 people on a radio. If I'm trying to do Wi-Fi and cover the football stadium, I'm not going to deploy thousands of APs or thousands of radios. So at that point, I might, you know, support 100 people on a single radio, but understand their experience, the quality of service, the capabilities, the user experience is going to be totally different in that environment, and you have to design the parts of your network for the needs of the individual. So once again, the more devices on a network, the more contention there's going to be for the network, and the lower the performance is going to be, bottom line. So how do you figure out that? How do you figure out how much is enough? And it's very, very important to understand how much bandwidth is actually available. Most of the time when we start talking about Wi-Fi, most people say that if it's a 54 megabit radio, if it's a 300 megabit radio, you typically cut that number in half, and that's about the amount of usable bandwidth you have. In reality, that works in a very controlled environment, but we all know that open Wi-Fi networks are not controlled. So it's actually even less than that. So if you've got a 2.4 radio, you've got about 150 megabit link is typically what you use, you can expect about 50 megabits of usable throughput, basically layer 2, layer 3 throughput that users can take advantage of. In a 5 gigahertz environment, you probably got a 300 megabit per second radio. You can get about 100 megabits per second. So in reality, where most people say it's about 50% of usable throughput, that's in a controlled environment. As you saw in that slide before, all these users, all these clients are going to connect at different data rates. You need to actually lower expectations there a little bit. Once again, if you can control your environment completely, you can get a little bit higher, but in reality, these are the numbers you have. So once you come up with those numbers, then you can actually start figuring out how many users I can put on a radio. So one of the things Gardner also recommended is, as a starting point, as a ballpark number, you can kind of figure about 6 megabits per user, which will give you a good experience. So using that math, this is where you come up with, on a 5 gigahertz radio, you can get about 50 users per radio. On a 2.4 radio, you can get about 8 users per radio. It's very, very important to understand these numbers. It doesn't mean if you have 9 or 10 or 12 or whatever that the service is going to degrade in any way. It all depends on what they're actually trying to accomplish. If you've got a classroom and everybody's doing high-definition video and everybody needs a 20 or 30 megabit pipe, you know, obviously you're going to have less people on a radio if you need to have a good experience. If you're just doing, you know, Wi-Fi in the cafeteria so people can, you know, get some email and stuff like that, obviously you could put, you know, with the Xeris product, you can put over 200 people on a single radio. But once again, you have to understand and design based on user expectations. Once again, what you do for a classroom, what you do for the cafeteria, what you do for the ballpark will be totally different levels of service. The other thing to understand is radio dynamics. Right now, there's 2 different bands available to operate in Wi-Fi. It's a 2.4 band and the 5 gigahertz band. Pretty much all your top-level devices support both. What's also important to understand is currently there are about 27 available Wi-Fi channels that can be used at any given time without interfering with each other. 85-90% of those channels operate in the 5 gigahertz band. Only 10 to 15% of those channels operate in the 2.4. So you need to understand that when you design your network. So in this environment, I've got 4 radios in here, 2 traditional APs. So I have 2 2.4 radios, 2 5 gigahertz radios. And as you can see in this design, if I have a 50-50 mix of clients, the 50-50 mix of radios works just fine. However, if I've got a lot of handhelds and stuff, I might have a lot more 2.4 devices. So in this case, I still got a 50-50 mix of radios because many of the devices out there, I can't change the radios. They're fixed in their design. So in this case, I got 75% of my clients are in 2.4, and I still got a 50-50 mix of radios. As we go forward into the future, more and more devices are going to support 5 gig, and I might have 75% of my devices on 5 gig, and I still only have a 50-50 mix of radios. What this is coming to is what you're starting to see now. More and more devices are becoming available with what's called multi-state radios. In this case, I've got 4 radios built in this device. Those radios can be set on 2.4 or 5. Basically, the radio itself can support either band. So in this case, I've got a 50-50 mix of devices, so I'll set up my radios in a 50-50 mix. However, if next week, next month, or even next period, I have a bunch of students come in and the vast majority of them are 2.4 clients, I can manually or dynamically even allow this device to switch to put 3 radios on 2.4 and maybe only leave 1 radio on 5 gig. And maybe a year later, a month later, or an hour later, I have a totally different mix in an environment. So now maybe everybody just showed up with their new iPad and they support 5 gig. So now I can put 3 of my radios on 5 gig and only leave 1 radio on 2.4. So the whole idea is that going forward, you definitely want to get away from the fixed state design. And what we're doing is mirroring what we did in wired many years ago. Many years back, if you got the gray hair like me, and I came out of Cabletron, you would sell a chassis, whatever, and you had a certain amount of 10 megabit radios and a certain amount of 100 megabit radios. And that was fixed design because obviously the 100 megabit radios were or 100 megabit ports were more expensive than that. But eventually went to environments where whatever I plug in, the switch port will adjust to it. That's what we're getting with Wi-Fi now. So based on what you have, I've got a radio. That radio will look at the environment or allow me to manually to set it in 2.4 or 5. Definitely what you want to do as we go forward, especially with 5 gig becoming the primary network connection, especially with AC. The other thing you need to do, obviously, is intelligent radios, more radios, controlling the amount of devices actually per radio is very, very key. And that deals with the performance issues of BYOD. The second issue with BYOD, obviously, is controlling the devices that come on the network. And that's where your network management comes in. That's where, obviously I can support these numbers of users, but I actually want to control them too. So network management has got really 3 different areas that you need to deal with in a wireless environment. The first is just a wireless network management, managing your wireless infrastructure. And obviously this is a little bit different than your wired infrastructure because you're also managing the RF environment, but it's very, very similar. You have SNMP, you gather statistics, you configure devices, you monitor performance, you generate reports. Obviously there's a little bit more concern in wireless for monitoring threats, rogue APs, clients that might generate some type of denial of service attacks. So wireless management has to be a little bit more granular and a little bit more controlled, let you see what the RF environment looks, good, bad, and indifferent. And also troubleshooting. Obviously, it's much more difficult to troubleshoot a wireless client than it is a wired client. Typically, a wired client, it works or it doesn't work, whereas a wireless client, what am I connected to, what data rates, it doesn't work here, it doesn't work there. So you have to have tools to monitor that, basically troubleshooting tools. The next set, basically, as I said before, is your network infrastructure management. The next part is actually managing devices. And what I mean by that is people show up with a lot of different devices on campus. They've got laptops, they've got tablets, they've got smartphones, they've got media players like an iPod, they've got Wii consoles and stuff like that. And if it's in the dorm, maybe it's great. Maybe you allow whatever happens in the dorm. But in the classroom, maybe I don't want students using smartphones in the classroom. Maybe I definitely probably don't want them using, gaming type devices. So the whole idea, and very important to understand, is that with wireless now, I can identify the type of devices on my network, whether it's a notebook, a phone, or a tablet. I can identify where they are. And I also can identify the type of device it is, whether it's an iOS, whether it's a Windows 7, whether it's an Android. And I can apply policies based on that, which gives me a little bit better control. So I can manage my infrastructures, and then I can manage and limit the physical devices based on their capabilities. The next step is then some classroom management capabilities. And for classroom management, I'm going to actually turn the presentation over to Kobe now and let him talk a little bit about what classroom management tools are all about.
Thanks, Barry. Yeah, let's talk a little bit about how classroom management can help in 3 key areas. I want to provide the ability to understand the activity in real time, a little bit of monitoring there, provide that visibility. At the same time, I want to understand and assess student understanding. And while that's going on, as Perry mentioned, the games, can I remove some digital distractions? So that's what we're going to focus on. There are really some challenges specific to classroom management and why folks look at solutions to solve these. So first off, how do we use technology to teach more effectively? How do we upgrade and increase that confidence leveraging this type of technology? As well as at the same time, I want to know that students are on task. I want to take away those digital distractions and provide a medium where they can have that level of classroom collaboration. So what classroom management does is it saves instructors time and it increases their confidence. At the same time, it's going to focus the students on the task at hand and remove those digital distractions. When everything is said and done, the teachers, the instructors, they can sit back and monitor the classroom and make sure that learning is actually occurring and not digital distractions taking that time away. So a very nice quote here about, we spent $45,000 on a lab and a $600 piece of software tripled the effectiveness. Let's go through and show some of that capability. So the first area is, how do I understand what is going on in my classroom? How do I see what's going on? How do I get that visibility? So what we've got here is obviously you need to have that real-time classroom activity. From this picture here, you can very easily see, okay, I've got some iPads in there, I've got some iPhones, a couple Macs, a laptop or two there with Windows on it, and even Linux. How do I gauge and understand across all of these platforms what's going on? The best model is to provide that real-time view for the instructors. Now, I want to know even more. I want to know, are they on? What's that current website? What is the current application that's running? And at the same time, as we can see here, Mr. Curley there, he has a question. So just by seeing the little question there, that teacher can reach out to Mr. Curley and help that student out to get that question answered. How do I type a formula into Excel? So this kind of information is important to not only understand the activity of the classroom, but also to reach out and help those students in need. Now, it's not just about keeping the teacher at the front of the classroom or the instructor. We want those instructors to be mobile while they're monitoring. So at the same time, I want to be mobile. I want to have this classroom activity on my iPad. I want to have it on my iPhone. And so that's what we can provide as well, the ability to let that instructor move throughout the classroom, help students, and yet have a single view of what is going on in their environment. The next area that is really key is the ability to assess that student understanding, to create a classroom of collaboration. There's some pretty unique tools and technologies here that take place. Today the world of having a projector at the back of the classroom and going to the whiteboard, that is one method. But a much better, much more rich environment is to provide the display right on my device, whether it's an iPad, whether it's a laptop, by using a type of technology to actually broadcast or share the teacher's screen, the instructor's screen, down to all of those devices. So you can see from this screenshot here that the teacher, the instructor has started an event, and they're going to browse the web together and can teach by doing what that instructor is doing there. In addition to that, as we mentioned earlier, we will have students that have a need for remote assistance. How can we provide a capability for that instructor to not distract the entire class, but yet reach out to those students in need? With remote assistance, you can do things such as reach out, remotely control one machine, help that student out, send that student a message. Maybe that student's playing a game. Send out a simple message. Please get back to work, and get those students back on task and doing what they need to be doing. Now, when it's all said and done, we've just taught a concept. We want to measure the amount of grasp that was given. The students can now respond to the teacher or the instructor with that information. Here's a great question. What is the most populated city in the world? And we just reviewed that concept. I I put out there a quick vote or question to the students, and I can get a real-time grasp of whether or not that student understood. And as you can see on the right-hand side, the iPad or the iPhone can respond just as simply as the other devices. We also want to provide the ability to, remove some of the manual testing process. Let me automate this. Let me give some of that time back to the teachers, and let the students leverage bring their own device or bring their own technology to take their tests. So the ability to deploy a test out there, watch students as they move through the test, and see, what are the areas that maybe a collaboration or a group of students are having a situation, and go back and potentially cover those concepts in a much deeper way in the future. All right, the last area that I want to talk about is a little bit about removing those digital distractions. How do we do that? So one of the very first things that a lot of instructors will do when they start classes, they want to focus the attention of the students, right? There's nothing worse than having a student working on email or playing the latest game and not focusing that attention on the instructor. We have, we want to provide the ability to facilitate taking away that digital distraction. So in this case, I can blank the screen for those students, have them focus on the instructor until the time comes where I re-engage them with their technology and let them have their keyboards, their mice, and their technology back. In addition to that, it's really important to control where they go. We want to maintain that they're in safe areas. We want to maintain that they're not going to inappropriate sites. We want to focus their attentions on the correct sites. So we can do everything from block all web browsing to just allowing certain websites to be available, or to just block certain websites, whichever model you would like to go with there. So controlling the internet access. Now, right along with controlling internet access, it's also key to be able to limit some of those games that they might be playing. For example, I may want to take away a little bit of chess, some free cell, and potentially solitaire in some environments. Right? I want to focus those students on the teaching and the environment at hand, and keep them away from those temptations to play those games. So why LAN School? LAN School is all about it being simple, it's easy. We build it on a reliable architecture, and one of the key things that you'll see is that we do support those multiple operating systems. We're more efficient on the network, and we definitely want to make sure that we're the solution to solve your bring your own device needs. We've been around for some time. Recently, LAN School was acquired by Stoneware. We've got tens of thousands of customers, over 5 million users worldwide, and really two key products. The first is a web-based IT delivery platform called Unified Cloud, and then the other is the first classroom management software out on the market, known as LAN School. So with that, let's take a look at a case study here. I was recently at a customer, Wasatch County School District, and this is a customer that has deployed both solutions, Xeris as well as the Stoneware environments. The key capacity, or the key thing here, is that with the Xeris technology, they are achieving high performances. They're getting the information across their environment and spreading that wireless access out there. At the same time, they're able to use LAN School to allow those teachers to monitor their classrooms and keep that learning experience focused. The integration between the two solutions is a captive portal. So through this portal, these students can log in, gain access to the network using the Xeris technology, and then LAN School assists that by letting them focus the attention. So a really key solution, a combination of the two products coming together there. All right, let me turn the time back to Perry to wrap things up.
All right, thank you very much. Moving along, as he just said, we both team together in the school district, and as I said at the very beginning, there's multiple components to supporting BYOD. Obviously, the one Xeris focused on really is dealing with the densities in the devices themselves, and obviously that's the first step, because if you can't get performance, I mean, I can put 200 users on one radio and get connected. I mean, basically they have a link, but obviously it's not going to be usable. So what Xeris focuses on really is kind of the lower layers as far as giving you performance, give you capacity, give you reliability, and giving you security for the number of devices you have. So as you can see here, Xeris does things a little bit different, and I know every marketing person tells you that. But we're the first ones really to come out with a modular switch. And basically what this means, instead of just deploying traditional 2 radio APs and just a bunch of 2 radio APs, what we do is we have solutions that are much more like the wired environment was 5, 10, 12 years ago, is that depending on what you need, you get different capacity. So I can deploy a 2 radio AP if that's all I need, if that's all my density and performance requirements are. Or I can deploy a 4 radio, or an 8 radio, or a 12 radio, or a 16 radio device. So basically, I can deploy a single device, basically running on 1 or 2 cables, that can support up to 16 radios in it. And these are all modular upgrade radios. So I can deploy an 8 radio device or an 8-slot device that only has 4 radios in it, and 6 months from now, if I need more capacity, all I have to do is plug in more radios. I'm not pulling more cables. I'm not deploying more devices. I'm not using more switch ports. I'm just upgrading that device by plugging in more capabilities, just like you would slide a new blade into a chassis. In addition, because each one of our radio modules there has its own dedicated directional antenna, we cover a much, much larger footprint, typically 4 times that of a traditional AP. So not only are these single devices giving you more capacity, the single device is also covering 4 times the amount of space as a traditional AP, which means you're deploying far fewer devices to cover the same area. And then finally, we have distributed intelligence. Our device is designed much more like a wired switch, where we don't have a back-end controller. There is no requirement to actually take my traffic from the array, send it to another device, decide what to do with it, and then forward its way out. Decisions are made, whether it's tagging, forwarding, QoS, filtering, whatever, at the array itself, and then the traffic is forwarded where it needs to go, just like you would in a wired switch type environment. And why this is important is because wireless is going to higher and higher performance. With 11A, with 11B, with 11G, processing everything to a single controller worked just fine because wireless wasn't seen as your primary network connection, and there wasn't the performance requirements on it. That's all changed. Now with 11N, I've increased the amount of bandwidth across my wireless network 5, 10, 15-fold. With 11's AC, we're even going to go higher than that, and you can't keep collapsing everything back to a controller. So the whole idea with the Xeris array, you have far fewer devices to deploy, far fewer devices to manage, and obviously you don't have the choke points or the single point of failures associated with a controller. On top of that, obviously the physical layer is very, very important. You need to have the performance, you need to have the capabilities, but you also need to have the services too. And obviously sitting on top of that is our service coordination. So whether it's security services, guest services, voice and video services, location services, performance service, and obviously monitoring and analysis type service, we have this functionality built in. And whatever additional functionality we need, we partner with companies like Stoneware with their Land School product to obviously give us best of breed as far as that capability. So once again, the array is the physical infrastructure. It gives you the performance. On top of that, it gives you your services to run a high-performance network. And obviously management, one of the obviously questions everybody have. We have an XMS management application, obviously full capability there, but obviously you can deploy it as an appliance type, you can deploy it as software, you could manage multiple sites from a single location, however you want to do it, and different sites and different individuals can get totally different rules. So once again, you can see what your environment looks like and you can control your environment. So bottom line with the Xeris differentiators, basically it's modular, which means it's actually the first product that's actually 11 AC ready. Probably Q3, Q4 of next year, you're probably going to see enterprise class AC products come to bear. There's probably going to be some other products out earlier this year. You're going to be able to open up an array, pull out an 11N radio, and plug in 11 AC module and just go forward. You're not going to have to re-pull cables, arrays, APs, or switch ports. It's already going to be there for it. All of our radios can switch back and forth between 2.4 and 5 gig depending on the environment you're supporting. More density, higher capacity, for up to 4 times the coverage. And obviously it's very, very easy to deploy with less cables, no controller, lower maintenance. So that being said, that kind of gives you an overview of the Xeris solution. And once again, if you want the 2 radio AP, yes, we can do that, but obviously the advantages of putting more devices, more capability in less devices is cost effective and obviously better for performance. So that just about finishes up this presentation. I want to remind you guys again that if you have any questions, definitely send it into the Q&A at the bottom, and we'll be answering Kobe and I will be answering questions shortly. So I'll give a couple minutes for a few more questions to come in, and then we can start answering some of the questions.
And as a reminder, if you'd like to ask a question at this time, please find the floating toolbar on the top of your console, select the Q&A option, also select all panelists, and submit your question.
All right, yes, we had a question come in related to what types of devices do you actually support with the classroom management solution? It's an excellent question. We support a number of devices. Let me just go through a few on the list here. Definitely support Windows, supporting the Mac environments. We do support Ubuntu Linux, the Apple iOS platforms such as the iPad, the iPhone, the iPod Touch. In addition to that, we can run on terminal clients as well as things like in computing. So a broad array of client devices that we support.
All right, thanks, Kobe. One of the questions that we've actually received several of the same thing is getting copies of the presentation. After the seminar is over, we'll send out a link to a recording of this presentation, plus you'll be able to get the PDFs. So that was a question that a lot of people have asked, so I should cover for it. One of the other questions that comes up, and to be honest with you, I hear this a lot, is if there is no controller, how does the management software work to manage the APs? It's very, very important to understand that the management software, our XMS application, however, manages the arrays just like you would a wired switch. And basically, I've worked in the traditional AP environment also. There's a common belief that all the traffic has to flow through a controller in order to manage that traffic or to manage that controller. That's not true. It's very, very important to look at it like you would an array is like a 24-port switch. Is that all the traffic from that 24-port switch doesn't have to go anywhere. I can gather it right from there. So with our management application, I can go and change configurations on the array just like you would switches. I can upgrade one array or 100 arrays at the same time. And obviously, I can manage all the statistics at the same time. Each array is its own managed entity, but obviously the arrays themselves, either they talk directly between each other, so even if I don't have a management application, the arrays themselves communicate with each other. But if I need to upgrade code or upgrade configuration or upgrade a setting, basically it's one click in our XMS management application, or even you can go into the web interface and do that the same way. And once again, I don't want to spend too much time on the subject, but yes, you definitely want to think of the arrays like you would a managed switch.
Yeah, it looks like a question came in related to how LAN School actually communicates across the network. We do support a 3 transport protocol. So using, across your wireless environment, we can go broadcast. We can also go across in multicast or what we call subnet-directed broadcast. So either of those models will work. Traditionally, a lot of folks will go, if it's going wireless and VLAN environments, they're going to go the multicast route or the subnet-directed broadcast route. As far as how practical is the limit to the number of those devices, we are based on what we call channels. And channels let us actually segment the devices into their own groups and thereby limit the amount of communication that occurs. So definitely, if you're interested in more information on the channel infrastructure, please go to lanschool.com and we'll get you some more information.
All right, thanks. We got a few more minutes we can talk. One of the questions came up is, how many users how many Wi-Fi devices can I actually connect to an array? That's a very, very tough question. I mean, in testing, I can actually say we can get just short of 2,000 users can connect to an array. That's what's possible. That's what we've tested with. Do you ever want to deploy a network like that? Probably not. We typically recommend about less than 20 people per radio to give you a wired-like experience, but it all depends on your expectations. So, I can actually say an array can support over 1,900 users. That's what we can test, and that's what we can prove in like an RFP. But the bottom line is, what are you actually trying to do? What performance requirements do you actually have? Along with that, there was another question that says, will devices such as smartphones, because of their design, slow down access to the Wi-Fi and performance? Yes, but it's very, very important to understand that. There was a common misbelief that the Wi-Fi network will slow down to the slowest device. That is not true. If I have a device that connects at 5 meg, another device that connects at 50, and another device that connects at 300, all sharing the same network, when they get the air, when they get the ability to send traffic, they all send at the highest data rate they can support. However, because I have a mixed environment, that device that can transmit at 300 megabits per second, it has to compete or contend with a device that only transmits at 6 megabits per second. So once again, They're both transmit at their max speed, but because I have to wait, it slows down the whole network. That's one of the ideas of why we want to take the high-speed devices like that can support 300 megabits per second, put them on one radio, and take the lower-speed devices that only support 6 or 10 or 12 or 15 megabits per second, maybe put them on another radio. Very, very important to understand that. Okay, let me. What sort of performance do you get from an array with multiple smartphones, tablets attached to it, as they don't have the power and the antenna length of a laptop? You're going to get whatever that device will generate. Once again, the array can't make that device transmit any faster than it's capable. And that's very, very important to understand, because there are a lot of people that think that, I've got so many handheld devices and they're 2.4 only, and there's going to be more and more devices like that. What's important to understand is that one of the features, there's some discussion about whether 11AC has a value. Why do I need to go to the higher gigabit speeds? It's not necessarily you need to go to the higher gigabit speeds, but with 11AC, if it's integrated to the handheld devices, even the lower data rates of 11AC will provide higher performance than what those devices are supporting today. So even if I have a smartphone that only supports one spatial stream, basically one antenna, it only doesn't support any bonding, doesn't support any of that, with 11AC, and once again, this is design, it's all kind of future type stuff, even at the low end, its data rate will be even higher. So that's kind of one of the advantages there. All right, let me look for... Okay, there was a couple questions about us versus competitors. We're going to try to keep this as vendor neutral as possible. If you really want to, get some more competitive information, you're welcome to contact Xeris or Stonewear Land School product directly. But that's not what we're going to get into on this call. Is there any documentation or literature available for the Xeris product? Yes, you can go to our website for that. There was
Looks like there was one more question that came in related to, we spoke about a captive portal. How does that work? With the combination of both Xeris and Land School and running things on those networks, we're able to actually achieve a delivery model where we can use a captive portal to deploy our agents. So the traditional model of let me install an agent on these devices is starting to become a thing of the past, and we're looking at new models where we can do things such as an on-demand agent that resides during the session and then goes away once the machine is rebooted or once they take that device home.
Yeah, and one other question, I guess since we mentioned AC, and one individual was asking, should they wait for AC to come out before upgrading their network? AC is really, once again, it's probably late next year before it's going to come along. Obviously, clients have to support it too. The majority of your clients are going to be 11N for quite some time. I would not, if you need to upgrade your network, I would not wait a year, because as you can see, we've seen anywhere from 30 to 80% jump in the amount of clients on a network just in the last quarter. So if your network needs to be upgraded, I think I'd move towards upgrading it now. But once again, you want to start looking at making sure that whatever solution you do purchase today is going to be upgradable in the future. Wireless is, as I said, it's kind of following about 12 years behind the wired network. If you're going to go buy an enterprise-class wired environment today, you're not buying fixed designs. You're buying chassis that can be upgraded, that I can pull out one board, slide in another. You want to start looking for solutions like that in wireless also. Wireless devices today are not really throwaway anymore. Obviously, they're getting more expensive, but they also have more capabilities and a greater mean time between failures. So you want to look for solutions, obviously, that support the multi-state radio type design, 2.4 or 5, whatever it happens to be, because that's what your clients are going to do, and it's obviously very dynamic in an education environment. And the second thing you want to think about is, 11N isn't the end point, 11AC probably isn't going to be the end point. So you want solutions that are going to be upgradable. Obviously, I'm very proud of the fact that the Xeris Array is the first upgradable, that I can replace one radio with another, and whether it's 11AC, 11AD, or another acronym coming down the line, the whole idea is you'll be able to replace that radio with a different radio, and maybe take the slower radios, which right now are the high-speed stuff, and maybe put it in another array in another part of your network. So the whole idea is that stuff's going to move around, it's no longer disposable. That being said, I'm going to give it a second and see if there's any more questions. Let's see. There's one. How do you assign low-speed devices to different radios as using the same SSID? Please reply here as my phone battery going down. Okay. What we do is basically what's called steering. When a device is talking, I can identify information about that device. I can identify whether that device is a 2.4 device or a 5 gig device, and I can encourage or steer that device onto a 5 gig radio if it can support it. Right now, devices, clients make decisions. There are standards coming down the pipe, 11V, 11K, and some others that are going to allow us as wireless vendors to have a lot more control over the clients. But right now, you can only encourage them to do so. I can steer a device to a 5 gig or a 2.4 radio. In addition, if I've got a 5 gig device that's only operating in 11A, can only support 54 megabits per second, and another one that can support 11N, I can encourage it to join an 11N only radio and put the other ones on 11A only radio. Once again, this information is advertised, it's available in the Wi-Fi environment, and you can control that. You can also set different limits as far as what your signal threshold is and your data rates are, that you can keep lower speed devices off your network. But you need to be very, very careful about that, because obviously in a public environment, in an education environment, you don't just want to say that, if you don't do 36 megabits per second, I'm not going to let you on the network. So you need to be very smart about how you do that. But those capabilities actually do exist. That being said, I think it's time. I'm going to throw it back to Josh and let him give the final information. I want to thank Kobe from Stoneware Land School for attending today.
Thank you.
All right, Josh, back to you.
Thank you, Perry. Thank you again for joining us today. This concludes today's web conference, and you may now disconnect. Have a good day.